driving the success of AI in modern times has been the emergence of successful machine learning algorithms and machine learning deployments. So we'll explore briefly the overarching concept of machine learning and explore how it plays out in some contexts. So if you see ML or machine learning, it's a key ingredient of any artificial intelligence system nowadays. So in fact, they're so close that sometimes AI is construed as ML systems. But we've seen AI is a broad concept, not necessarily ML itself, but a whole bunch of other concepts imbibing intelligent behavior into a machine. In particular, machine learning is basically a concept based on three broad notions. Machine learning is said to be the phenomena in artificial intelligence, whereupon if an object has a lot of experience at certain task, it could be historical experience or experience it gains through performing some task. The historical experience encoded in data is used to arrive at a certain model or pattern or some formula or some kind of a summarized knowledge representation which has an impact on the performance of a task by means of bringing about what we call as an improvement in the performance. So if you see, there are three elements. One is historical experience, or we call it experience knowledge. Then we have some notion of performance of an agent or a machine, or it could be an AI task, intelligent task, some unit of performance. Then the idea is you will use the historical experience to improve the performance by arriving at a model or some kind of a knowledge abstraction or pattern, etc., which will enable this improvement in the performance. So all four elements are important. Well, three key elements are capturing of the historical experience. Second is the notion of an objective performance function. It could be how we can do driving better, or how we can recognize a face better, or how we can predict stock price better, or how we can classify a spam mail better. Then using the model or the knowledge extracted from the historical experience, how you produce an improvement in the way you've been performing. So, improvement in performance is key, leveraging of history and experience is key. Third is an objective notion of performance and task is also key. So let us instantiate this concept in several examples where machine learning is used in practice. Let's take the simplest example of spam classifier in email, right? So what is historical experience in spam? It is basically a collection of mails flagged as spam or non-spam. So you have a whole bunch of collection. Then performance notion is prediction accuracy of spam given a new mail to the spam filter, right? Then what is the M here, which is the model built from historical experience, known as? It's basically a classifier. What's a classifier? Classifier is something which is, assuming for now a black box, which is able to, given a new incoming mail, able to classify it into ham or a spam mail. Now, we want to see that the accuracy of prediction improves with time as we apply the model from classification. So what happens is, as you give more and more data, suppose you collected a good amount of data from historical, you flagged them, and then now you have created a classifier, which is a sample, what you call model, representing the historical knowledge. Now when an incoming mail is coming, you have to classify them into correspondingly the ham or spam, and your prediction accuracy actually improves with time as you get better and better models with more and more experience knowledge gained and creating better and better classifiers as we go in time. So if you see here, we have examined all the three elements: notion of historical experience, notion of performance, which is predicting whether something is ham or spam, how accurately you predict it. Then you have something known as a model, which is used for improving the performance. Now, assume the same thing. We want to look at it in the context of, say, a stock prediction. So what we've seen in case of stock prediction is, we have historical data over, say, past few months of, say, a specific stock. Let's take, for example, a stock of a company like, say, IBM. And that becomes a collection of data points from, say, past 5-6 years. Let's assume that we're talking 99, 2000, and so on. So we have last 20, 25, 27 years of data of the stock price. And that becomes a historical data of, historical experience data of the stock. So what is output parameter here is basically how accurately, suppose you're predicting corresponding point for a point of time, what is the corresponding error in prediction from the actual value. So in that case, what we're talking about is historical knowledge is about, at a particular time, what was the value of the stock. Then in case of the performance, it's about, performance here is the error, which is difference between predicted and the actual value. Now, what you do is you improve the performance, means decrease error over time by producing better and better model. In our case, model is nothing but, it is known as a regressor, or it is a curve fitting function, which is basically a equivalent of a machine learning model, but for continuous variables, which actually tries to estimate the output in terms of function of several other input variables. And its idea is to predict what will be the point of value of a particular stock at a future point. So what happens is, here we have historical experiences, different times and other factors are captured and corresponding value. Then you have performance in terms of how accurately you are able to predict stock value and how much is the difference from actual. Then your model is actually an equation which is able to display what the behavior of your historical data is looking like. I don't want to specify here what the regressor is. Is it a neural network? What kind of knowledge is it? Is it an equation? Is it a decision tree? Is it a linear equation, or is it just a correction of probabilities? That's basically beside the point. The point is, there is a black box regressor. It has a certain performance, which is basically a notion of error. And the idea is, as you perform better and more, give more and more data, the performance of the function improves over time, means the error decreases with time. So, if you see here, machine learning has this basic aspect of these common these four elements: a lot of historical data, notion of a performance, notion of a improvement of performance based on a model generated from historical data. So that, in essence, gives you a key idea of what machine learning is all about.